Hello students, we are now going to move to the next solid of the chapter, which is a cylinder. And we are going to begin with the net of a cylinder. So click on this link to watch a short video which is going to take you through the net of a cylinder. After you have gone through the video, try this activity of making a cylinder yourself. All right. Now, what are the formulas for a cylinder? Here we are given a cylinder with radius equal to r and height equal to h. The curved surface area of a cylinder is equal to 2 pi r h, and the total surface area will be the curved surface area plus the area of the top circle and the bottom circle, which is going to make it 2 pi r square. And the total area is going to be 2 pi r into h plus r. These are some real life examples of a cylinder. This is a Coke can. These are batteries, a mug, a gas cylinder, and a cylindrical trash can. We are now going to begin exercise 13.2. And I'm going to start with the first question of the exercise. The curved surface area of a right circular cylinder of height 14 centimeters is 88 centimeters square. Find the diameter of the base of the cylinder. Now here, the CSA of the cylinder is given to you. That means 2 pi r h is equal to 88. Put the value of h, which is given to be 14 in the question, and the value of radius will come out to be 1. But the question is asking you to work out the diameter, so double up the value to work out the diameter of the base as 2 centimeters. Question number 2. It is required to make a closed cylindrical tank of height 1 meter and base diameter 140 centimeters from a metal sheet. How many square meters of the sheet are required for the same? Now, what is your quick observation when you read the question? What we notice here is the difference of units. The height is given in meters and the diameter is given in centimeters. So we are going to make the units uniform. Now the radius here is 70 centimeters, which I'm converting as 0.7 meters. The second observation that you have over here is that the cylindrical tank is closed. That means you would be taking the area of the sheet as the TSA of the cylinder, which is 2 pi r into h plus r. Substitute the values over here, and after you have finished your calculations, the area will come out to be 7.48 meters square. Next question, question number 3. It's an important question. A metal pipe is 77 centimeters long. The inner diameter of a cross section is 4 centimeters. The outer diameter being 4.4 centimeters. Find its inner curved surface area, the outer curved surface area, and the total surface area. Now here, the inner radius is going to be 2 centimeters, which is given in these figures. The first figure is giving you the inner diameter, and half of this is going to be the inner radius. The outer diameter is 4.4 centimeters, which is given by the second figure. So the outer radius is going to be 2.2 centimeters. But since you have 2 radii in the question, you cannot keep the notations the same. So the inner radius is being taken as small r, and the outer radius is being taken as capital R. What is the inner CSA? It's 2 pi small r into h. Substitute the values. The area comes out to be 968 centimeters square. Similarly, the outer CSA will be 2 pi capital RH. Put the values. The area will come out to be 1064.8 centimeter square. Now that's the pipe that you would be looking at for the area. Here you can easily make out that it's going to be the outer CSA plus the inner CSA, and the top and bottom circles are going to be in the shape of rings. So the total surface area is going to be the inner CSA plus the outer CSA plus twice the area of the ring, because there is a ring at the top and there is a ring at the bottom. Now inner CSA and outer CSA you've already calculated. What is the area of the ring? It is the area of the outer circle minus the area of the inner circle, which is pi capital R square minus pi small r square. Since there are two rings, the bracket is going to be multiplied with 2. So substitute the values that you already have as answers in the first two parts and substitute the values for the remaining part of the step. So when you substitute the values over here, I'm applying a plus b into a minus b, which is giving you 4.2 into 0.2. And when you multiply and add the steps, you get the total surface area as 2038.08 centimeter square. Question number 4. The diameter of a roller is 84 centimeters and its length is 120 centimeters. It takes 500 complete revolutions to move once over to level a playground. Find the area of the playground in meters square. Remember, the units are given in centimeters, whereas the area needs to be taken out in meter square. The radius of the roller is 42 centimeters. One revolution is going to be the CSA of the roller. So area of the entire playground is going to be 500 revolutions into the CSA of the roller. Substitute the values, R and H is given to you. Multiply, you will get 15840000 centimeter square. Now separate 10,000 centimeters square from this value. 10,000 centimeters square is equal to 1 meter square, and you get the area of the playground as 1,584 meters square. Question number 9, again, it's a good question. Find the CSA of a closed cylindrical petrol storage tank that is 4.2 meters in diameter and 4.5 meters high. How much steel was actually used? If 1/12 of the steel actually used was wasted in making the tank. Now the radius of the cylinder, 2.1 meters. CSA, you have to work out the CSA in the first part. So the formula is 2 pi r h. Substitute the values and you will get the CSA as 59.4 meters square. Now you also have to work out the total amount of steel used. So I'm taking that to be X. The question says 1/12 of the steel actually used got wasted. So the wastage is 1/12 of the total amount, which is X. So what is the amount of steel used in making the closed cylindrical tank? It's going to be 11/12 X. So 11/12 X is going to be the TSA of the cylinder, which is 11/12 of X into the CSA has already been worked out. So substitute the value here. And the second part you will need to calculate. That is giving you 11/12 X is equal to 87.12. So X comes out to be 95.04. Therefore, the total amount of steel used before wastage is 95.04 meters square. Question number 10. In the figure, you see the frame of a lampshade. It is to be covered with decorative cloth. The frame has a base diameter of 20 centimeters and height of 30 centimeters. A margin of 2.5 centimeters is to be given for folding it over the top and bottom of the frame. Find how much cloth is required for covering the lampshade. Now, as you can see in the figure, the lampshade is in the shape of a cylinder. Now, this is a real life example. If you can recall a lampshade, the lampshade does not have circles at the top and the bottom. The circles are open. So here, the radius of the lampshade is equal to 10 centimeters. The total height of the lampshade, including the folding of the cloth is going to be folded inside the top and the bottom circles, which are open. That's going to give you 35 centimeters. So area of the cloth required for the lampshade is going to be CSA of the cylinder. Substitute the values, you will get 2200 centimeter square. The students of a Vidyalaya were asked to participate in a competition for making and decorating pen holders in the shape of a cylinder with a base using cardboard. Each pen holder was to be of radius 3 centimeters and height 10.5 centimeters. The Vidyalaya was to supply the competitors with cardboard. If there were 35 competitors, how much cardboard was required to be bought for the competition? Now, as you can understand, a pen holder is also a real life example. A pen holder has a closed bottom base. That means the circular base at the bottom is closed, but the top circle does not exist. So the area of the pen holder is going to be the CSA of the cylinder plus the area of the base, which is 2 pi r h plus pi r square. Substitute the values in the formula. Everything is given to you, and you get the area of 35 pen holders as 7920 centimeter square. Now, questions 5, 6, 7, and 8 of this exercise, you will try yourself. Here is your challenge question. You can see the figure very clearly. In the figure, on a face of a 10 by 10 by 10 centimeter cube, a cylindrical hole of height 3 centimeters and radius 2 centimeters is removed. Find the surface area of the remaining object. So try this challenge question. That's it for this video. Thank you all for watching the presentation.